Let's talk about how we can solve for x when x is inside an absolute value sign. Remember, absolute value always returns a positive answer. And I wanted to just draw your attention to this, that, if I were to, let's say, take this equation, you can see x minus 4, so shifted to the right 4 units, and up 2, so over 4 up 2. There's my absolute value graph. If I were to say, when is this equal to, let's say 5, now that says what x's make a y value of 5. So here's 5. You can see there are 2 answers, 1 and 7, that do that. So you need to be aware, much like a parabola, there are 2 solutions here. And I'll explain where those 2 solutions come from. Okay. If I could just solve this, then let's start this way. Much like the other problems we've done that involve parabolas or square roots, I would take this piece and I would just ignore it, leave the absolute value for the end. So I would begin by subtracting 2 from both sides, get down to just the absolute value. And at this point, we create 2 problems to solve. One of them is that x minus 4 is equal to 3. The other is that x minus 4 is equal to negative 3, because both 3 and negative 3 have an absolute value of 3. So we need to figure out when this is either 3 or negative 3. So I add 4 to both sides in this problem and in this problem, and there's 1 and 7. There are my 2 solutions. So once you have your absolute value piece, then you just set that equal to both the positive and negative versions of the answer you want. Now, one thing similar to square roots for certain, there's a graphical component to this that we need to be aware of. And what I mean by that is, if I were to say, okay, hey, when is this equal to negative 1? You come down here to negative 1 and say, well, never. This graph never gets to negative 1. And how I would catch that is, when I subtract 2 from both sides and I get negative 3, you have to say to yourself, well, can the absolute value ever return a negative answer? No, there's no solution to that. It has to be a positive answer over here, much like the square root had to be. You can't have an output that's negative. That's not in its range. Okay, so be aware of that. Check that as you solve. All right, let's do some that don't involve the graph. Here I've got 2 times the absolute value of 3x plus 1 plus 6 equals 20. So I am going to just absolutely work around this to begin with. Okay, so we're going to subtract 6 from both sides. We're going to divide both sides by 2. So I have the absolute value of 3x plus 1 equals 7. At this point, I just stop and say, is 7 a possible output in absolute value? It is. Negative 7 wouldn't be, but positive 7 is. Now I make my 2 problems. 3x plus 1 is 7, or 3x plus 1 is negative 7. Subtract 1. I'm going to do this kind of concurrently. So subtract 1. Divide by 3. Divide by 3. This isn't a nice answer. So there are my 2 solutions. Let's do another one. Okay. 4 times the absolute value of 2x plus 1 plus 7 is negative 5. Let's begin solving. And just remember, we're going to kind of leave this piece untouched until it's the only thing remaining on that side. So subtract 7. Divide by 4. Now, stop and ask yourself, Is it possible to take the absolute value of something and get -3? The answer is no. We need to get a positive number out of absolute value. So this one has no solution. Let's do one more. 5 times the absolute value of x plus 6 minus 4 is equal to 11. Leave this till the end. So I'm going to add 4. I'm going to divide by 5. Now, the absolute value of x plus 6 is equal to 3. Is 3 a possible output of absolute value? The answer is yes, because it is possible to get a 3. You can't get a -3, but you can get a 3. So now we proceed to our two problems. X plus 6 is 3. X plus 6 is -3. Subtract 6. Subtract 6. And here are our two solutions. If this video helped you, please like and subscribe for more math help.